Now, one problem that you'll commonly come across when you're measuring a system is sometimes systems are really big.
Right.
There's a lot of data you could collect.
Right.
And it may be very time intensive, may be very costly to collect all of the data. Maybe impossible to collect all of the data.
Yeah.
So what do you do? How do you get a good measurement?
Well, you can hopefully try and get like a really representative cross-section and sample that.
That's exactly it.
Okay.
This is a concept called sampling.
Okay.
And basically what you're doing is you're taking a random subsection of the system that you're looking at, and you're examining that, and then you're using it as a proxy, which we'll talk about what a proxy is in a moment. But you're using that as an example to represent the entire system. And so, a good example is in order to save costs, a lot of manufacturers won't inspect every unit that comes down the production line. They'll inspect like 1 in 5 or 1 in 20. And if they find an issue, they can typically shut down the system well enough to identify all of the product that didn't work or that had an issue or whatever, and then restart the line. So they don't have to examine every one. They just examine, things at random or, on a pre-specified schedule. And that allows them to get pretty much the same result with a lot less time and a lot less effort.
Okay.
Now, some people kind of object to the idea of sampling, right? It's like, how can that be accurate? You're just taking some random thing and measuring it. Like, how can that be real?
I can see, like, with food safety stuff, that would make me nervous.
Right.
But with, like, are all the toys working? Something like that, I could see.
It really depends on how critical it is. So, if you're inspecting fuel rods for nuclear reactors, you're probably going to inspect every one because it's really important. Something bad could happen if it goes wrong.
Yeah.
But if you have some margin for error, sampling is a way that you can conduct good measurement without spending most of your resources on inspecting everything that you produce.
That makes sense.
But it's kind of counterintuitive, right? Because
it makes you nervous.
Yeah, it's like, well, what if we miss something?
Right.
And there's actually a huge part of probability and statistics that deals with sampling.
Oh, yeah?
But the good example in terms of, or an analogy in terms of if you can rely on it or not. Quote I came across a little while by Jean Fulgiani. I'm not sure where they're from.
Yes.
But it says, if you don't believe in sampling theory, next time you go to the doctor and he wants to take a little blood, tell him to take it all.
Ew.
Right? Well, you can't do that, right?
Okay, I'm convinced.
You can't do that. But it's a good analogy. A little sample of blood, you can test that and to see the state of the entire system.
I get it.
So sampling is a really good approach if you can't measure everything.
Yeah.
But you can get enough information to figure out if there's some issue, something that you need to test.
Okay.
And that is sampling.